This is Chapter 2, Lesson 5, Percent of Change. Okay, so we're on page 38. Over at the top left-hand corner, it says words. A blank, blank, blank is a ratio that compares the change in quantity to the original amount. So in those three blanks, you're going to write percent of change. Okay. So percent of change is a ratio that compares the change in quantity to the original amount. So if I'm looking at my equation, percent of change equals the amount of change over the original amount, okay? That equation is very important, okay? So the amount of change over the original amount equals the percent of change. All right, so in this first box, it says, when you compare the amount of change to the original amount in a ratio, you are finding the percent of change. The percent of change is based on the original amount. If the original quantity is increased, then it is called a percent of increase. So increase means go up, so percent of increase. If the original quantity is decreased, then it is called a percent of decrease. Okay, pretty straightforward. If it goes up, it's an increase. If it goes down, it's a decrease. So the percent of increase is the amount of increase over the original amount, and the percent of decrease is the amount of decrease over the original amount. So let's take a look at the problem below. It says, find the percent of change in the cost of gasoline from 1970 to 2010. Round to the nearest whole percent if necessary. So gas from 1970 cost $1.30, and gas from 2010 costs $2.95, right? So since 2010 is greater than the 1970 price, this is a percent of increase. Okay, so gas 1970 was $1.30, and gas from 2010 was $2.95. Okay, so step one, I want to find the amount of increase. So I subtract them. I take $2.95 minus $1.30, and I get $1.65. That's my amount of increase. Okay, then I want to find the percent of increase. So I take the amount of increase over the original amount. The original amount was usually the first amount that they mentioned in the problem. In this case, it's 1970, which is the original amount. 1970 became before 2010. So 165 over 130 is approximately $1.27 or 1.27. I'm looking for a percent, so I have to multiply by 100. When I do that, I get 127%. Okay, so the cost of gasoline increased by about 127% from 1970 to 2010. All right, so here's a try it problem. Go ahead, try it out. Make sure you follow the steps, pause the video, and when you come back, we'll go over the answer together. All right, now that you've tried the try it video, or tried the try it problem, let's go over the answer together. The price of a radio was $20. It is on sale for $15. What is the percent of change in the price of a radio? Okay, so first, is it an increase or a decrease? Right, it's a decrease. The price went down. So step one, I have to find the amount of decrease. So I take my prices and I subtract them. 20 minus 15 equals 5. Okay, now I'm going to take that over my original price. 5 over my original price was 20, so 5 over 20. Now I divide. 5 divided by 20 is 0.25, which I then multiply by 100, which gives me 25%. So the price of the radio is decreased by 25%. On page 39, we have this second half of percent of change. So it says the blank blank is a ratio that compares the inaccuracy of an estimate or amount of error to the actual amount. So in those two blanks, you're going to write percent error. So percent error is the ratio that compares the inaccuracy of an estimate or amount of error to the actual amount. So the equation, identical to percent of increase, right? I take the amount of error, so I subtracted them, over the actual amount or the original amount. So finding the percent error is similar to finding the percent of change. Instead of finding the amount of increase or decrease, you will find the amount an estimate is greater or less than the actual amount. So let's take a look at the try it problem. Or let's take a look at the problem they give us. So it says Ahmed wants to practice free throws. He estimates the distance from the free throw line to the hoop and marks it with chalk. Ahmed's estimate was 13.5 feet. The actual distance should be 15 feet. Find the percent error. So step one, so here's my two numbers. 13.5 and 15. So I subtract them. 15 minus 13.5, 1.5 feet. Doesn't matter which one you put first. Recommend that you put the larger number first so you get a positive number. Step two, find the percent of error. So I take the amount of error, which was 1.5 feet, over the actual amount. So that's the actual distance, was 15 feet, right? So 1.5 over 15, I divide that, I get 0.1, multiply by 100, or 10%. So the percent error is 10%. All right, now let's look at the try it problem. Go ahead, pause the video, try the try it problem out, and see what you get when we come. All right, so now that you've had a chance to try the try it problem on your own, let's go over it together. So the try it problem says find the percent error if the estimate is $230 and the actual amount is $245. Round to the nearest whole number. So as you can see, I've highlighted the two numbers that you will need, 230 and 245. So step one tells me I need to subtract. So I'm going to subtract 245 minus 230. When I do that, I get $15. Now, step two tells me I'm going to take the $15, which is my amount of error, and I'm going to divide it by the actual amount, which was 245. When I do this, I get approximately 0.6. When I multiply that times 100, I get 6%. And that is the end of lesson 5. All right, I also want to talk a little bit about this foldable here on page 40. So this is attached to lesson 5, chapter 2, lesson 5. Okay, so this is the percent of change and percent error foldable. So it's just a reminder of how you find the percent of change, percent of increase, percent of decrease. Okay, gives you examples and the percent error. So, and some of you may have had to cut this off, its amount of error over the actual amount. Okay, so you take the actual amount minus the guess over the actual amount. All right, and that is on page 40 for your reference.